here. Yeah, screen. No. Yeah. Okay. All right. So, apparently they thought they assigned the code to another group, so you had to create a new code. So whatever code we got now, we'll continue to use that for the rest of the time, hopefully. We have 3 more classes after this. Our last class is on the 30th of April, and the exam would follow the week after that. So hopefully we have no more hiccups before that time. Okay. So I was looking at this question. I think I can't remember who asked the question about number 20. Are you all seeing the screen?
Yes, we can see.
Okay, yeah. So someone asks this question about number 29. And so I was just going through the process of how we would work out the which of those combinations would give you the result at the top. So because we are using this factoring method, we use a little bit of logic to figure out what combination could be for the first and the last term, but the middle term is where we have to now work out which of them would give you that middle term. We know for sure all of these combinations we have at top would give us the first term, and all of these that we have at the bottom will give us the last term. Now remember, this is a trinomial, and the trinomial has 3 terms. And so the first term, 6x squared, the possibilities are up top here. And the last or the third term, the possibilities at the bottom. But the middle term, we have to now try and figure out. And to get the middle term, we have to multiply these two, the first and the last, or and these two, the middle. So 6 times negative 6x times negative 2 gives you minus 12x, and minus 2 times x gives you minus 2x, and that together will give you 14x, but we have 17. So we know that this one won't work. So we could rule out using negative 2 as your last term for the two binomials. Okay, so if we can't use negative 2, then we would have to either use negative 1, negative 4, negative 4, negative 1. So we could do that. So we go back again and try 6x. We could say minus 4 and x minus 1. So we try 6 times, that gives you minus 6x, and 4 times that gives you minus 4x. That gives you minus 10x. So that's not going to work either. So we could now switch it around. We have 6x and x, and then we could try now 6x minus 1 and x minus 4. So if we multiply this with that, 6x times that gives you 24 minus 24x, and x times that gives you minus x, 1x, which gives you minus 25x. So that doesn't work either. So we could rule out the 6x and the x as our starting terms, because we're not getting that middle term using the 6x and the x. So either way we put the -1 and -4, that's not going to work. So we could rule that out. Okay. So the other option we have then is to use the 3x and the 2x. Okay, so let me go and start with 3x. Okay. And 2x. And let's see, we're going to try with -1 -4. Let's try that. -1 -4. So we multiply this. 3 4s are 12, so that's -12x. And 2 times 1 is 2, -2x. That gives you what? 14x. -14x. So that's not what we want. So let's go again. We're going to do 3x again. But this time we're going to put -4. And then 2x -1. So we're reversing. So first we use -1 -4. Didn't work. So we're going to try -4 -1. So we go here. 3 times 3 times 1 is 3x. And what's this here? 4 times 2 is 8. That's 3x plus 4 2 is 8. Sorry. Let's cross that out. All right, so 3 times x, that's -3x. And then -4 2's, that's 8x. So we're getting 11. Okay. Now let me see here. 4 2 is 8, 3 1 is 3. Number 29. Let me see if we wrote the right thing here, because I think there might be a problem with this question. Which question is this again? 6.5. 6.5. This was question number 20. 6.5. 6.5. Um, 29. Oh, sorry. I just realized what we did. I wrote the wrong thing. It should be 6x squared minus 11x plus 4. So this middle term should be minus 11x. Yeah. All right. So this one that we just did then, -3 minus 8, that gives us the negative 11x, which is what we were looking for. So 3x squared minus 4 times 2x minus 1 would give us the result. That would be the factorization of this. So that should be equal then to 3x minus 4 times 2x minus 1. Okay. So basically then it's a bit of trial and error that we're going to use. we definitely know how to get the first, what combinations will give us the first, and what combinations will give us the last. But then once we decide which combinations we're going to use, we're going to have to try out the different combinations of those to see which would give you the middle term. And that would be what we'd use to do the factorization of that particular expression. Okay, so we just made a mistake at the beginning here and put 17 when it should be 11. But none of those gave us 11 anyway, just this one that gave us the minus 11. Okay, so we're going to move on then to look at today. We're going to finish off chapter 7, looking at factorization of equations and using the factorizing method to solve. And then we're also going to look at the formula, and then we move on to the beginning of chapter 7. So in 6.5, we had gone to a certain point, but right here now we are at page 355. On page 355, they are looking at the process of solving equations by factoring. So here it says a quadratic equation in X is an equation that can be written in the form ax squared plus bx plus c equals 0. And a, b, and c must be real numbers, and a cannot be 0. Okay, because if a is 0, it means that then this first term would end up being a 0, and it won't be a quadratic equation anymore. All right, so because this equation is equal to 0, we can use what is called the zero product principle. And the zero product principle says that if you multiply two numbers and their product is 0, then one of the numbers have to be 0. So in other words, if you have a times b and a times b is equal to 0, either a going to be 0 or b is going to be 0. Okay, one of them, the only way you could multiply two numbers and to get an answer of 0, one of the numbers have to be 0. Okay, and we could use that principle to help us to solve quadratic equations. So we use that principle because it says if you write the equation in this form where it's equal to 0, we can factor the equation. And when we factor the equation, then it's going to say that either one of those factors have to be 0. And so we could solve each of them as if each of them was 0 and get the solution for our equation. And we're going to look at that on the next slide. Okay. Now, right here, the study tip, it says the method does not apply if the equation is not factorable or if it's prime, because some equations cannot be factored. So if an equation cannot be factored, we can't use this method to solve that equation. Okay. So we have an example here where you have x minus 5 times x minus 2 is equal to 0. So the products are x minus 5 and x minus 2. So we have two binomials that multiply to give 0. But because of this zero product principle, either x minus 5 is equal to 0 or x minus 2 is equal to 0. Now, they didn't go through the full working here to get the value of x, but if x minus 5 equals 0, it means that x must be equal to 0 plus 5, because you're going to move the 5 over. So x is equal to 5. So that's how we get this x equal 5 here. And if x minus 2 is equal to 0, x minus 2 equals 0, that means x will be equal to 0 plus 2, x equals 2. So x is either equal to 5 or 2. So you'll find with quadratic equations, you generally have two solutions because you are looking at the square. You're not just looking at x, but you're looking at x squared. So two numbers multiply to give x squared. So in most cases, you're going to get two answers for the value of x. And you could check your answer by substituting each of those answers into the equation and see if you get a true result. So for the first one, it says x equal 5. So this was x minus 5, x minus 2. So you put you put 5 in place here. So this is x, this is x. So 5 minus 5, 5 minus 2. 5 minus 5 is 0. 5 minus 2 is 3. 0 times 3 is 0. It's a true statement. If x is equal to 2, you're going to put the 2 in place of x. So put 2 in place of x. 2 minus 5, and that is negative 3. And 2 minus 2 is 0. Negative 3 times 0 is 0. So that's true. So it says the resulting true statements indicate that the solutions are 5 and 2. The solution set is the set containing 5 and 2. Okay, so two possible answers, because when you factorize it, now there are times when you have one answer. You could have, for example, x minus 5 times x minus 5. So in that case, x minus 5 would be the same for both factors, and so it would be just the one answer, x equal 5. But in many cases, you will find two different possibilities. So you'd have to give two answers for x. Okay. So I want you to look at this one here. This says x plus 6 times x minus 3 is equal to 0. How could we go about solving that? Using the zero principle, zero product principle. I have to call names. Let me call names then. Let me see. Miss Nan, tell me what's the first step?
Okay, so using the zero principle, we know that one of the numbers have to be 0, right?
One of the products, yeah.
Right. So then we would substitute the first x with 6.
Well, okay, so we'd say either x plus 6 equals 0 or x minus 3 equals 0. Okay, so in order for us to get a 0 here, either this here have to be 0 or this other one have to be 0. So that's your zero product principle. So if you want to put that there, 0, you don't have to put it, but I just put it here so you could see what principle we use. Zero product principle is either one of them have to be equal to 0. So
x will be 0?
No, x plus 6 is 0. So how would you find x? If x plus 6 is 0, how would you find x? X plus 6 equals
Also,
0.
then you say 0 minus 6.
Okay, so x equals 0 minus 6. So x would be equal to what? What is
Negative
0?
6.
Negative 6, okay. Or x equals what?
0 plus 3.
0 plus 3. So x equals 0 plus 3 is
3.
3. All right, so our solution is x is negative 6 or 3. Okay, and so if you want to check your answer, you could say, let me put check here. You're going to put negative 6 in place of x. So you're going to say x plus 6, x minus 3 equals 0. So if you're using negative 6, you're going to say negative 6 plus 6, negative 6 minus 3. Negative 6 plus 6 gives you 0. And -6 minus 3 gives you -9. So 0 times -9 is equal to 0. Okay, so that works out. That's true. That's okay. And if you use the other one, which is 3, so let's do the one. This is x plus 6 x minus 3 equals 0. So if you use the 3 now, the positive 3, you would say 3 plus 6 times 3 minus 3. 3 plus 6 is 9. 3 minus 3 is 0. 9 times 0 equals 0. So that's also true. So it works for both. Okay, so that's your 0 product principle application to solve a quadratic expression. So once you have the quadratic expression factorized, you can solve it using this approach. All right. Now, in this other example, you don't have the equation written already factorized like what we here. Here we have it already factorized. Okay, so here we just have a quadratic expression that's not factorized. So this is saying x squared minus 2x equals 35. But in order for you to use that principle to solve your quadratic, you have to have it written so that all the terms on one side and equal to 0. So what we could do, it says the step 1 is to move all terms to one side by, well, they say subtracting 35 from both sides, but you could move 35 to the left hand side. And so if you move the 35 to the left-hand side, it becomes minus 35. So x squared minus 2x minus 35 equals 0. So now we have a quadratic equation that's in this general form of a quadratic equation. So if I look back here, remember, quadratic equation, the general form is to be in this setting here. A number times x squared plus a number times x plus a constant equals 0. So when it's not written in that form, we can always rewrite it like this form to make it be in the standard form of a quadratic equation. So all the terms are on the left and equal to 0. So once we do that, then we can factorize it. And so when they factorize it, they got x minus 7 times x plus 5. 5 sevens are 35, and that's negative. So that's negative 7 times positive 5 gives you negative 35, and x times x is x squared. And then 7 minus 7x gives you minus 7 times x gives you minus 7x, and then 5 times x gives you 5x. Negative 7 plus 5x gives you the negative 2. So this is the factorization of that. So once you factorize, now you can go ahead and solve either x minus 7 equals 0 or x plus 5 equals 0. So once you know that x minus 7 equals 0, it means that x must be equal to 0 plus 7, which is 7, or x must be equal to 0 minus 5, which will give you negative 5. So x is either 7 or negative 5. And you could always check your answer by substituting the 7 into it. So if you put 7 in place of x, that's 7 squared minus 2 times 7 equals 35. So 7 squared is 49. 2 times 7 is 14. 14 take away 35. Sorry, 14 take away 14 is equal to 35. So that's true for this one. And then we check it with negative 5. So you're going to have negative 5 squared minus 2 times negative 5 equals 35. That's the original equation you had. So negative 5 times negative 5 is a positive 25. Negative 2 times negative 5 is a positive 10. 25 plus 10 is 35. So 35 equals 35 shows that the equation, the values that we got were correct. So we had two possible answers, either 7 or negative 5. So I want you, okay. All right. So I want you to try this one, x squared minus 6 equals 16. First, you're going to write it in the standard quadratic equation form. Then you're going to factorize it. Then you're going to solve. Give you a couple minutes to do that. Today is the 2nd of April. Okay, Ms. LaRochelle, tell me what you did so far.
So far I have x squared minus 6x minus 16 equals 0.
Mhm.
Then I have in brackets x plus 2 and x minus 8.
Okay.
And x plus 2 equals 0 and x minus 8 equals 0.
Or x minus 8 equals 0. Mhm.
X equals 0 plus 0 minus 2.
Mhm.
And then x equals 0 plus 8.
Mhm.
That's as far as I got. But to check it,
So x, if 0 minus 2 gives you what?
-2,
And 0 plus 8?
+8.
Okay. All right. So x is equal to -2 or x is equal to 8. And then you could always check your answer by substituting it into the equation to see if you get. Okay, so if you do the first one for x equal -2, then you would say x squared, that would be -2 squared minus 6 times -2 equals 16. You could check to see if that's the case. So -2 squared is 4, and minus 6 times -2 gives you positive 12. 12 plus 4 equals 16. So that's true. And then for the next value, you have 8. So you're going to say x equals 8 here. So you're going to substitute 8 squared minus 6 times 8 equals 16. Okay, so 8 squared is 64. And 6 8's 48. And sorry, what I put here? Yeah, 64 minus 48. Do we get 16?
Yeah.
Yeah, we
Yeah.
get 16, right? So that also works. Okay. All right, so the check is optional, but it's always helpful to do it so you could know if you're on the right track. Okay, so that's your check. So our actual answer then is x equal -2 or x equal 8. Okay, so we have a little one that's a little more involved here. So we have 5x squared minus 33x plus 40 equals 0. So we already have all the terms on the left-hand side being equal to 0. So what we need to do is factorize. So once you factorize, as they got here, they got 5x minus 8 times x minus 5 equals 0. So same procedure again, we're using the zero product principle. So it's going to be 5x minus 8 is 0, or x minus 5 is 0. So if 5x minus 8 is equal to 0, then 5x would be equal to 0 plus 8, which is 8. So if 5x is equal to 8, then means x would be equal to 8 divided by 5. And then on this side, x minus 5 equals 0. So that means x is equal to 0 plus 5, which is just 5. So the two answers we have here is x is equal to 8 over 5, or x is equal to 5. And you could always check those to see if they work to see if you're on the right track. Okay, so let's try this one here. First, you have to factorize. Then from factorizing, you should be able to solve for x. Give you a couple minutes to work on that one. Okay, Miss Nairn, tell me what you did so far.
Okay, so I did open bracket 2x plus 2 x minus 2
Okay,
And then I did 2x plus 2.
hold on now. Are you're gonna get, you're gonna get 7x there
No,
in the middle? You remember now you have to get that 7x. Let me see if you do 2x. Okay, 2x squared. 2x times x will give you the 2x squared, and then 2 times that will give you the minus 4. But then when you do this times that, you get 2x, and this times that gives you 2 2's 4. So no, that's not going to give us the 7x in the middle.
okay.
So you need a different combination. Did you try 4 and 1?
No, okay, so
Okay, so let's try 4 and 1. Let's see, 2x and x. Okay, let me see, 4 2's. So you could use 4 here, and you could use 1, and you're going to get a positive 4 and a minus 1. So the logic of that is that, okay, 2x times x will give you 2x squared, minus 1 times positive 4 will give you a negative 4. And then you're going to use the 4 times 2 to give you 8. And then minus 1 times x would give you minus 1x. So 8 minus 1 would give you what?
oh, a 7.
Right. So we have to, so the getting the first term and the last term is the easy part. Okay, but now we have to also try to make sure whatever we use for the first and the last, there are different things we could use for the first and the last, but we have to make sure that we get the middle term with those combinations. So to get the middle term, we have to multiply first and last, and then the inner ones. So in this case, 2x times 4 will give you 8x, and minus 1 times x gives you minus x. 8 minus x equals 7x. All right, so that's the one we're going to use. So we're going to say then that 2x minus 1 times x plus 4 equals 0. All right, so now that we have factorized it and we know that those two equal 0, how are we going to solve for x?
So then we say 2x. 2x is equal to 1.
Okay, 2x minus, well, I like to go fully with the 2x minus 1 equals 0,
Mhm.
or x plus 4 equals 0. Then
Okay.
now you're going to say 2x equals 0. When you move the 1 over, it becomes
Positive.
plus 1, or x equals 0
Minus.
minus 4. So if 2x equals 0 plus 1, that means 2x is equal to 0 plus 1 gives
1.
you 1, or x equals 0 minus 4 gives you
Negative 4.
negative 4. All right, so if 2x equals 1, that means x would be equal to,
1 divided into 2.
okay, so x is a half. So answer is that x equals 0.5, or x equals negative 4. Okay, so those are two possible answers for x. Okay, so now that method we used just now is for solving equations by factoring. Now, as was mentioned before, those there are some equations which we cannot factor. Those equations we call prime. They cannot be factored, but we could still solve them. We could solve them using the formula. All equations, all quadratic equations could be solved using the formula. But the formula is a little bit tedious. And so if you see an equation where you could factorize it to solve it, it may be quicker to use the factoring method than to use the formula. And in fact, the formula needs some kind of memorization. You have to remember that formula, whereas if you, with the factorization method, you don't really have to remember a formula. You just have to know how to factorize it. But like I said, sometimes it's not so easy to factorize some equations, and some equations you cannot factorize. So you could use the formula in any event. So it says then the solutions of the quadratic equation in the form ax squared plus bx plus c is equal to 0. So before you can use the formula, you must have your equation written in this form right here, the standard form of a quadratic equation. Okay, so all the terms on one side equal to 0. Okay, so once you do that, the formula says x is equal to negative b squared plus or minus, this is two operations that you see here, plus or minus the square root of b squared minus 4ac all over 2a. Okay, so you will see the explanation here. X equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. And the study tip emphasize that all divided by 2a says here the entire numerator. So all of this at the top is your numerator. It says the entire numerator of the quadratic formula must be divided by 2a. Always write the fraction bar all the way across the numerator. Some people tend to only write it partially. It needs to be all the way across, okay, when you're doing your working. So please note that, because that's an area where a lot of students make mistake. Okay, so this is the formula: minus a minus b, or negative b, plus or minus b squared minus 4ac all over the square root of b squared minus 4ac all over 2a. So let's look at an example of a question that you could use the formula to solve. So you got this formula: 2x squared plus 9x minus 5 equals 0. So once the formula is expressed in this form, you can figure out what a is. A is the coefficient of x squared. So in this case, a is 2. B is the coefficient of x. In this case, it's 9. And c is the constant. That's the number without a variable. And this case is negative 5. So once you identify what a, b, and c is, then you're going to substitute it into the formula. So minus b squared is your formula first. So b is 9. So you're going to put negative 9. Plus or minus b squared, which again is 9, minus 4ac. So that's going to be minus 4 times a is 2, and c is negative 5. And all over 2a. So 2 times a, and a is 2. So that's how we do that. So now we're going to have then negative 9 plus or minus 9 squared is 81. And then minus 4 times 2 is 8, minus 8, and minus 8 times minus 5 gives you a positive 40. Okay, and then we are going to now add the 81 and the 40. And by the way, 2 2's 4 at the bottom. So you add the 81 and the 40, you get 121. So it's negative 9 plus or minus the square root of 121 over 4. The square root of 121 is 11. So that's what we have here. So it's going to be negative 9 plus or minus 11 over 4. Okay, So
Sorry,
because we,
go over it again when you finish.
okay, no problem. Because we have a plus or minus here, that is telling us that we have two possible answers for this. Okay, so this is going to be -9 plus 11 or -9 minus 11. So that's how you see it. So the first answer is going to be x equal to -9 plus 11 over 4. -9 plus 11 is 2. 2 over 4 works out to give us a half, 0.5. And then on this side, we're going to look at -9 minus 11. -9 minus 11 is -20 over 4. -20 divided by 4 is -5. So our answer is going to be half or -5. Okay, so I'll look over it and see. Let's see something here. Okay, so we're going to go back over that. Okay, so go back. This is the formula to solve a quadratic equation using the quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. So this is a formula for you to memorize. Minus b squared plus or minus square root of b squared minus 4ac, the square root of that, all over 2a. Okay. So the equation we have here, if you want to write the formula, let me see. X equals, okay, minus this again. Minus b plus or minus square root of b squared minus 4ac all over 2a. Okay. So from this equation, we can see that a is equal to 2, b is equal to 9, and c is equal to -5. And so the next step then is to put those numbers in place of the variables in the equation. So that's our first step. So we said b is 9. So that's going to be negative of b. So b is 9 and negative of b would be -9 plus or minus b squared. B was 9, so that's going to be 9 squared minus 4 times a times b. A is 2, b is 9. Sorry, 4 times a times c. So 4 times a, which is 2, times c, which is -5, over 2a. So 2 times a, and a is 2. Okay. So first thing we do, work out what's under the square root. 9 squared is 81. Minus 4 times 2 times -5 gives you 40. Then we continue to work out the under the square root. 81 plus 40 is 121. Of course, here 2 times 2 is 4, so we carry the 4 across. Okay, so once we finish this, then if you can find the square root of that, you go ahead and find the square root. The square root of 121 is 11. So once we find the square root of 121, we don't need to write the square root sign anymore because we worked out the answer to be 11. So -9 plus 11 over 4 or -9 minus 11 over 4. Remember when we are solving the quadratic using the factoring method, we got 2 answers. So we're still going to get 2 answers even though we're using the formula, but we're going to get our 2 answers because right here it says plus or minus. So one answer would be when we add, one answer would be when we subtract. Okay, and so that's how we get the 2 answers. So this here is the answer, the working for when we're adding. So it's going to be minus 9 plus 11 over 4. And then here we have the answer for when we are subtracting. So that's going to be minus 9 minus 11 over 4. And so minus 9 plus 11 gives you 2. 2 over 4 works out to half. Minus 9 minus 11 is equal to minus 20. So minus 20 divided by 4, which is a positive 4, will give you a negative 5. So that's the second answer. So you finish off by saying x is equal to half or negative 5. So no matter what type of quadratic equation you have, once it's solvable, use the formula to solve. Okay, so you don't have to factorize. But some equations, you could see the factorization right away. So the work would be much shorter if you factorize.
Colin, I have a question.
Yes, ma'am.
So if, let's just say this equation had x squared plus 9x minus 5. So we would say A is
Okay, so
what?
let me just hold on now. You say x squared
Plus
minus or plus
plus 9x
mhm,
minus 5.
minus 5
So
equals 0.
right. So then would A then be 1?
Yes, ma'am.
Okay. All right.
Mhm. Okay. Okay. So let's look at this one here, number x checkpoint 10. So for this one, what is A?
8,
A equals 8. B equals
2,
and C equals
1,
not 1,
-1.
negative 1. Okay. All right. So let's write the formula out. X squared equals, what's the formula? Oh, sorry. I said x squared, not x squared. X. What's the formula? The formula for quadratic equations?
It's negative B
Negative b,
plus or minus
plus or minus,
B squared minus
square root,
square root B squared minus 4AC over 2A.
all over 2a.
2A.
Mhm. Okay. All right. So I want you to go ahead and substitute the 8, the 2, and the minus 1 into that and solve it. Okay, somebody need to mute there. Okay, so let's look at that. Let me see. Miss, what do I have there? Okay. Miss Pratt, are you able to respond? Are you there? Okay. Miss Pratt. Miss Nairn?
I'm here.
Mm-hmm. So when you substituted, tell me what you got.
When I substituted, I got -2
Mm-hmm.
plus or minus square root 2 squared minus 4 multiplied by 8 multiplied by -1
Mm-hmm.
over 2 multiplied by 8.
Mm-hmm. Okay.
So then x is equal to -2 plus or minus square root 4 minus 32
Minus 4 times 8 is
32
that's -4 times 8 now.
-32
And then -32 times -1.
is 32
Okay, that's plus or minus 32.
plus
Okay, so that's plus 32. Okay, and all over
16.
16. Okay, all right.
So then x is equal to -2 plus or minus square root 36 over 16.
Mm-hmm.
X is equal to -2 plus or minus 6 over 16.
Mm-hmm.
So x can be 4 over 16
Okay, so that's -2
plus
plus
6
over 16, which is equal to 4 over 16, which is equal to 1 over
1
4,
over 4,
or
or
X.
x could be -2 minus 6 over 16.
Mhm.
This is equal to -8 over 16. 2, no, 1 over 2.
-1 over 2.
Sorry, 1 over 2.
-1 over 2. Okay, right. So X is either 1 over 4 or -1 over 2. Miss La Rochelle, you follow?
Yes, I have that.
Okay, all right. Okay. Okay. Now, in this other example, we have a quadratic equation, but it's not written in the standard form. So it says 2x squared equals 4x plus 1. So all we have to do first is to rewrite it in the form before we could use the formula. So we're going to write it, put the 4x and the 1 on the left-hand side. Of course, when you move the 4x, the sign changes. When you take it over the equal sign, because you actually have to subtract 4x from the two sides. And the same thing with the 1. The opposite of the add would be to subtract from the two sides. So you're going to end up with 2x squared minus 4x minus 1 equals 0. And then, so once you get that, now you know that A is equal to 2, B is equal to -4, and C is equal to -1. And from there, you're going to use the formula. You're going to substitute the values in there. Now you notice here, this was supposed to be -B, but B was -4. So we're going to have -4 plus or minus. Oh boy, they didn't put the square root over the whole thing. Okay, the square root sign should go over the whole of this. But anyway, so plus or minus -4 squared minus 4 times 2 times -1. That's 4AC. A is 2, C is -1, and B squared, that's -4 squared. So you going to now have 4 plus or minus -4 squared is 16. And then -4 times 2 is -8. -8 times 1 is +8. Well, they didn't, okay. They just, okay. So it's still going to end up, okay, 16 plus 8 is 24. All right. So it's going to be 4 plus or minus the square root of 24 over 4. Now, in the ones that we looked at before, you end up with a perfect square. This is 36. Square root of 36 is 6. Here we ended up with 121. The square root of 121 is 11. But sometimes we don't get perfect squares. So in this example, we didn't get a perfect square under the square root sign. We got 24. So when you don't get a perfect square, you could still go ahead and evaluate. But in this book, what they prefer you to do is to leave it in radical form. So you'll see in their working, they left the answer in radical form, but you have to be careful when you're doing that. So what they did here, if you remember when we were doing radical form, this is 4 plus or minus the square root of 24 over 4. So this here could be simplified because what number could divide this now? What they did, oh, I see what they did here. Square root 6. We have 16. I'm trying to figure out how they jump from 24. Okay, so the perfect squares we have 1, 3 3s 9, 2 2s 4, 16. Okay. Solving for the two equations, they got this 4 plus or minus 2 square root 6 over 4. And so they left the answer in that form rather than try to work out the square root of 24. And so we have, and I want you to note on the side here, they show where you could actually work out the result using a calculator, find the square root of 24. And so if you say 4 plus square root of 24 divided by 4, you get the 2.2. And it's an approximate answer, it's rounded off. But in this book, they didn't actually work it out to that point. They simply leave it in radical in the radical form. Okay. So in the bottom here now, they mention here to avoid these common errors by factoring the numerator before you divide. So they're showing two things that are incorrect. So sometimes people try to cancel out, but you can't just cancel these two because this is a plus sign or minus. All right, so you can't do any canceling here. And then also some persons try to cancel in this case. Again, you can't cancel because you're ignoring this 4. Okay, so it says you cannot divide just one term in the numerator and denominator by the greatest common divisor. So you have to be careful when you try to cancel here. Now this is page 358 of your book. Let me see. X square root 2, I think. Okay. Now in your book, I'm trying to follow in your book. This is page 3. I think they probably made some kind of mistake here.
Yay. See?
So in your book, they have it a little bit more broken down. Somebody needs to mute. Who is this?
This is coconut water.
Hello, Miss Pratt? Okay, so right here, if you remember when we were doing the radical, that would be 4 plus or minus. Now the square root of 24 would be 4 times 4 6s are 24, right? It's over 4. So that's equal to 4 plus or minus, the square root of 4 is 2. But we can't find the square root of 6, so we leave it as square root 6. I mean, we could find it, but we'd have to estimate it over 4. So that's how they got this to be 2 square root 6 here. Okay, so they simplified it as 4 plus or minus 2 square root 6 over 4. And now if you're trying to cancel, you can cancel 2 into 2. 2 into 4 is 2. 2 into 4 is 2. And 2 into this is 1. Okay, so here what they're trying to show you, you can do canceling, but you can't just cancel 1 at the bottom and 1 at the top like they did in these 2 examples. So if you cancel, you could cancel this and that and this and that. Okay, so you cancel the 2 in front of it. This is 2 times square root 6, and then you cancel with the 4. So you have to cancel straight across. You can't just cancel a portion of it. And that's what they're trying to explain right here. So if you find a factor that could divide the bottom and divide both of the terms at the top, then you could go ahead and cancel. All right. But if you can't cancel both the terms at the top, if there's a plus or minus sign between them, then you can't just cancel 1. So that's how we reduce this now to 2 plus square root 6 over 2. Okay, so plus or minus square root 6 over 2. And so your answer could either be 2 plus square root 6 over 2 or 2 minus square root 6 over 2. All right. And so if the number under the radical is negative, well, we don't have square root of a negative number. So it means then that there are no real solution. But in this case, the numbers are positive under the square root sign. So we do have 2 real number solutions. Okay. So they left the answer in radical form here instead of trying to estimate it like that was done here.
So with that calculator workout, they only have one possible answer. So that's
Yeah, it really should be 2. I guess they were just giving an example. So this is the one for 4 plus. So if you want to do the one for 4 minus, then you would find 4 and then find the square root of 24, subtract it, then divide by 4. Okay. Yeah. All right, so let's try this one here. 2x squared equals 6x minus 1. Go ahead and try and work that out. First, you have to write it in the standard form of a quadratic equation. Then use your formula and go as far as you can go and see if you could simplify it in radical form. I think this one will have to be in radical form as well. Okay, Miss La Rochelle, tell me what you did so far.
Sorry, I didn't get this started. I was dealing with my daughter.
Okay. All right, you could still explain what you think you should do if you can.
Okay, A is equal to 2.
Before you get to that, you have to rewrite it.
2x squared minus 6x plus 1 equals 0.
Okay.
A is equal to 2. B is negative 6. And C is 1. So the formula will be negative open bracket, negative 6 close bracket, plus or minus square root of open bracket, negative 6 close bracket to the power of 2 minus 4 times 2 times 1 over 2 times 2. With the square root, it'll be positive 6 plus or minus open bracket 36, negative 36 minus
Negative 36.
positive 36
Mhm.
minus 8 over 4
Mhm.
6 plus or minus the square root of 28 over 4
Mhm. All right, so can we simplify this further?
we can.
Mhm. The square root of 28. Can you simplify square root of 28?
Well, it's not a perfect square.
Right. So because it's not a perfect square, we could still find a perfect square that could divide 28, 6 plus or minus. What perfect square could divide 28?
4,
4. Okay, 4 times what give you 28?
7.
4 times 7. Okay. So in that case, then we could say 6 plus or minus. So the square root of 4 is,
2.
so that would be 2 square root 7 over 4. All right. So now that we have a 6, we have a 2, we have a 4. So these three have a common factor.
So 2 could go into 4 2 times.
Mhm,
So 2 and a 2 is 1, 2 and a 6 is 3.
mhm. So that would be equal now to 3 plus or minus square root 7 over 2. All right.
Yeah.
So if you want to, I mean, you could always rewrite it as 3 plus square root 7 over 2, or 3 minus square root 7 over 2. Those are the two possible answers. Okay. So it's
Okay.
either that or that. Yeah. Okay. All right. So because we didn't get a perfect square for 28, I mean right here, then we can try to simplify it as best as we can and leave the answer in radical form. Now, yeah, for this course that we're doing, yeah. Now, if you're doing like PGCSE or some other exams, they would want you to find the square root of 28 using your calculator and then add it to the 6 or subtract it from the 6, as the case may be, and then divide by 4. But for this course, we could leave it in radical form. So even if you leave it like this right here, let's say this question was worth 5, 6 points, you would probably get 4 to 5 points. Let's say it was 6 points, you would probably get 5 points up to here, and then the simplification of it would give you an additional point. Okay. In fact, you know what? 6 points, you get 4 if you left it right here, because you want to simplify it and then expand to show that it's this or that. So 1 point would be for this portion here, and then another point for stating that it could be this or that. Okay. So, but the bulk of the points would be gotten for bringing it up to this point. Okay. Okay. So we have application using quadratic formula, but I think I'm gonna skip that for now. Basically, it's still using the formula, and this time they're using decimals and so on. But it's once you follow the formula correctly, you should be able to figure it out. So I'll leave that. But there are some application questions that you could use quadratic equations to solve. This one has to do with blood pressure. Strangely, there seems to be some connection between age and pressure. And so they're showing you how you can figure out what the pressure should be based on age. And it varies between men and women. So you could look at that when I send the slide to you. And then there's another checkpoint relating to that. But I want to move on to the graphing section since the time is running. We started a little late because of the issue with the link. But I want to move on to look at the graphing of which we're going to be looking at a little bit more next week when we graph equations. So graphing, first thing we're going to look at is plotting points. And I guess all of you should remember the basics of plotting points, and we refer to it as a coordinate system, rectangular coordinate system, because we actually have squares on a plane that we use as our reference points for graphing. And then we're going to just look at the process for actually graphing an equation. Okay. So on the graph paper that I sent you, you would see, I think I sent you one with 4 quadrants where the axes are already numbered. And then I sent you another one which was not numbered. Okay. So on our graph, in order for us to graph on a grid or graph paper, we need to have reference points. So the 2 reference points we have are the X and Y axis. The X is the horizontal, the Y is the vertical. The point at which the 2 of them intersect is called the origin. So that's right here. The 2 lines intersect here, that's the origin. And we call that origin 0, 0. Okay? The zeros meet right here for both axes. So on the horizontal, the negative numbers are on the left, positive numbers on the right. And on the vertical, the negative numbers are at the bottom and the positive numbers are at the top. We number our, because those 2 lines intersect, it divides the plane or the flat surface into 4 quadrants. So this here is the first quadrant, and we go anti-clockwise. The second quadrant, the third quadrant, the fourth quadrant. Of course, quadrant comes from the word quarter, meaning that you break up something into 4 parts. Okay, so 4 quadrants are formed when the 2 axes intersect. And this quadrant here, you will see that you have positive number to the right, positive numbers going up. On the second quadrant, positive numbers going up, negative numbers to the left. In the third quadrant, both axes are negative. In the fourth quadrant, the horizontal is positive, the vertical is negative. Okay, so that's the basics of how your coordinate system is made up of. It's made up of 2 axes that intersect to divide the plane into quadrants. And each axis is numbered, and the numbering system varies according to what scale we want to use. But right here now, they're using 1 unit for each square on each of the axes. Okay. So in order to ensure that we all follow the same method, we have a universal conventional process for plotting points on the graph. We have what we call ordered pairs, and each point in the rectangular system coordinate corresponds with an ordered pair in the order X, Y. X would be your X-axis, Y would be your Y-axis. X would be how far you move horizontally, and y would be how far you move vertically. Okay, so the first number is called the x coordinate. All right, and the second number is the y coordinate. Okay, so on this graph here, we have 2 points that are plotted. This first point is it says 5, negative 5, 3. So because the first one is for the x, you're going to go on the x-axis, look for -5, and then on the y, you're going to look for 3, which means you're going to have to move up because positive numbers are up from the x-axis. So if you want -5, 3, you move to -5 and then move up 3, and you put a small dot here to indicate the point that we are looking for. So it's going to be at this point. The next one was 3, -5. So you go to 3, +3, and -5 means you're going to go down 5. And so this is the point where 3, -5 is. Okay, so a basic review of plotting points. So we have a few more points here to plot. So in this first one, it says 3, -3, 5. So we go to -3 and we move up 5, and we call that point A. So it's labeled A. That's point A, -3, 5. The next one was B, which is 2, -4. They go on the x-axis to 2, and because the second number is negative, you're going to go down 4. So that's the point B right here, 2, -4. C is 5, 0. So the first number again is on the x-axis, so you go to 5, and on the y, 0, it means you're not going to move. You're going to stay right here. 5, 0 is this point here. For the next one, D, -5, -3. So you're going to go -5 on the x, and then because the second is negative, you're going to go down 3 places, 5, -3. Right here, that's point D. Point E is 0, 4. So you're going to go on the x-axis to 0, and then it says 4, so you're going to go up 4. So that's point E, 0, 4. And the last one is 0, 0. Of course, we said 0, 0 is the origin. So you get 0, 0, it's always going to be right where the two lines meet. And so that's point F right here. Okay. So let's look at these examples here. So we have a grid and we have some points to plot. So let's see, Miss Nairn, Miss Pratt, not with us. Miss Nairn, I guess I'm gonna have to get to on you then to answer these. Miss Nairn, I mean.
I'm here.
Okay. Oh, Miss Rochelle said power gone. Okay. Not sure how long it take to come back. Okay. So it's just you right now, Miss Nairn, because Miss Rochelle said the power went where she is. Okay, so A, -2, 4. Let me wait.
So -2, that'll be on your left-hand side to -2, and then up to 4.
Okay, so that's right here then. All right, so that's point A. And then the next one says 4, -2.
So that'll be to your right, X, and down to -2.
Okay, so that's that, right? That's B.
C would be negative left to -3, right on the line that says 0.
Okay, so you're gonna stop right here. That's going to be C, yeah.
And then D will go down -3. Right on the main line.
Okay, so you're gonna go to 0 and then down that to A, so that's gonna be right here, and that's gonna be D. Okay, all right. So that's the basics of plotting points. The first number tells you where to go on the x-axis, And then the second number indicates whether you go up or down, following the number system on the y-axis. Okay. So our next task now is to actually graph equations. Okay. So it says a relationship between two quantities can be expressed as an equation in two variables, such as, for example, y equals 4 minus x squared. A solution of an equation in two variables, x and y, is an ordered pair of real numbers with the following property. When the x coordinate is substituted for x and the y coordinate is substituted for y in the equation, we obtain a true statement. Okay. The graph of an equation in two variables is a set of all points whose coordinates satisfy the equation. So basically, all the equations that we have looked at so far, we can draw graphs of them. Some equations produce certain types of graphs. So for example, you will see later that the quadratic equation produces what is called a parabola, which is a curved graph, whereas the linear equations produce straight line graphs. And these graphs can be useful because they can actually help us with some solving of certain real world problems. And so that's why the use of graphs are helpful. Okay, so we're going to look at the process for graphing using the point plotting method. So with the point plotting method, what we do is we're going to basically do up a table and use a certain range of points to work out the value for x and y, and then we could plot those points on the graph. So it says here, we find several ordered pairs that are solutions of the equation, plot the points, then connect them with a smooth curve or line. So in this case, we are looking at the equation y equals 4 minus x squared. So they want you to select integers for x, starting with -3 and ending with +3. So that's what this means. X such that x is greater than or equal to -3 or less than or equal to 3. Okay, so what we do is, in this case, the equation we have is y equals 4 minus x squared. So they ask you to use -3 to +3. So we start with -3, then -2, then -1, then 0, then 1, then 2, then 3. And once we choose these points for x, we're going to substitute that in the equation and work out what y should be. So if x is -3 here, y would be equal to 4 minus -3 squared. So y equals 4 minus -3 squared. -3 squared is 9. So 4 minus 9 gives you -5. So when x is -3, y would be -5. So this is the point, -3, -5. When x is -2, then we're going to say y would be 4 minus -2 squared. -2 squared is 4. 4 minus 4 is 0. So we're going to get -2, 0 here. When x is -1, then y would be 4 minus -1. 4 minus -1 squared. -1 squared is 1. 4 minus 1 is 3. So at this point, where x is -1, y would be 3. And we continue the process all the way down using 0, using 1, using 2, using 3. And so once we get the value for y, we could form our what we call ordered pair. And so we usually try to choose a few. In this case, they have 1, 2, 3, 4, 5, 6, 7 different points. Okay. And so once you get all the points, you plot them. Now plot the 7 points and join them to form a smooth curve. So the first point was -3, -5. So that's this point right here. Then the next point was -2, 0, which is right here. Next point was -1, 3. -1, 3 was right here. Then 0, 4 then 1, 3, then 2, 0, then 3, -5. And so we use a pencil and just join the points. In this case, try to make it a smooth curve, as smooth a curve as you possibly can. And so this is what we call, this type of graph is called a parabolic graph, okay? Because of the shape. So it's P-A-R-A-B-O-L-A. And all quadratic equations form this type of a graph. So once you see a graph like this, you know you have what is a quadratic equation where you're looking at the x being squared, x squared. The power, the highest power of the variable is 2. Okay, so let's see what we have here. Okay, so now in this checkpoint, you're asked to graph y equals 4 minus x. Select integers for x starting with -3 and ending with 3. So we're going to do the same thing for this one. This is slide 30. Let me see. Okay. 30. All right. So we could use the same procedure. We're going to do x and then y. And then we're going to use -3, -2, -1, 0, 1, 2, and 3. The equation we're looking at is y equals 4 minus x. So to find the y value for the first one, let me see who else. Okay, Ms. Nan, tell me what you're going to do for the first one. If x is equal to -3.
Okay, so x is equal.
Hello?
I'm here.
Yeah, you're saying?
Okay, so then if x is equal to -3, then y would be 4 minus -3.
Right. So y would be what?
4 minus. So then y would be 1.
No. 4 minus 9, -3 would be 4 plus 3.
Would be 7.
7. Okay, so that's 7. So our first point then would be -3 and 7. Okay, let's look at the second one.
So that'll be y would be equal to 4 minus -2. So y would be equal to 6.
So that would be -2 and 6, right?
Y equals 4 minus -1. So y will be equal to 5.
So that would be -1 and 5.
So y will be equal to 4 minus 0. Y will be equal to 4.
So that would be 0 and 4.
Y equal to 4 plus 1.
Why you say +1? The
Oh,
formula.
no, sorry, 4 minus 1.
Okay.
So y will be equal to 3.
Okay, so that's going to be 1, 3.
Y equal to 4 minus 2. Y is equal to 2.
So that would be 2, 2.
Y equal to 4 minus 3. Y is equal to 1.
So that would be 3-1. Okay. All right. So we have now created some points to plot. And so we're going to start off now. Let's see with the first one, which would be -3, 7. So you go to -3 on your x-axis. Now, if you're doing axis, I think I gave you one where the axis is already labeled for you, but if you don't have it labeled, then you should make sure to put X on your horizontal and Y on your vertical, and then you number them. And then right here should be 0. So -3, 7, would you go to -3 and up to 7, so that would be right here. Then -2, 6, you're going to go to -2 and up to 6, so this would be here. Then -1, 5 would be there. 0, 4 would be right here. 1, 3. 1, 3 would be here. Then we have 2, 2. And then 3, 1. Okay, so are we getting a curve like the first one?
No.
No. Okay, so this one looks more like a straight line. So once we get a straight line, then we'll have to use a ruler and rest it against the points and try to join them to make a straight line. So let me see, I will try to, let me see, I get this a straight line. Okay, so you join the points together like that, and you could write the equation on the line. Y equals 4 minus x. And so that's your graph of the line y equals 4 minus x. You clear on that?
Clear.
Okay. All right. So now, okay, let me see. All right. Now in this example that we did, the axes were numbered 1, 2, 3, 4, 5, 6, 1, so on. But sometimes you may have larger numbers than what we have here. So you may need to adjust the values in your axis based on the numbers you're working with. So sometimes you may have to use, you might have to go up in twos, 2, 4, 6, 8, 10. So if you're going up in twos, then you know if you want 1, you'd have to go halfway between the 0 and the 2. If you want 5, you'd have to go halfway between 4 and 6. And then if you have larger numbers, you may have to use 5, 10, 15, 20, 25. But whatever you use on one axis, the same thing have to apply on the other side, okay? So you make sure whatever you use on one side of this axis, you have to use the same thing on the other side. And on the vertical, the same thing applies. So whatever you use up top as your scale, you have to do the same at the bottom, okay? So depending on the numbers you have to work with, you may have to adjust how you number this, but it must be uniform, okay? So in this example they're looking at here, they're asking you to use the group graphs to solve this. So they have a formula, y equal 2.5x, and this is if you have a discount pass, and then without discount pass, they're looking at this other formula. And so they ask you to let x be 0, 2, 4, 10, 12, 14, and 16. So right away, if x is these larger numbers, then you wouldn't be able to use these numbers here to graph it because you're already gone up to 16. So you would have to adjust your scale to be able to fit the information on the graph. So they give the working using what they suggest, 0, 2, 4, 10, 12, 14, 16. It says 0, 2, 4, 10, 12, 14, 16. Based on the first formula, which is y equal 2.5x, which we have here, they worked out the values. If x is 0, 2.5 times that would be 0. 2.5 times 2 would be 5. And so they work out these different possible values for y based on the value for x. And then there's another formula they had, 21 plus x. So that's the other formula. So one is with the pass and one is without the pass, one is with the pass. And so they then plot it, but you will see here, in this case, because we didn't have any negative numbers, so we didn't need to use this type of graph where you had the negative axes. So they only used the positive axes, and you notice they went up here. They went up 4, they skip 1, 8, skip 1, 12, and so on. So they're going up uniformly, 4, 8, 12, 16, 20. And on this side, they use a different scale, 5, 10, 15, 20, and so on. So you don't have to use the same scale on the vertical and the horizontal, but if you had extended this horizontal to the left, whatever scale you use on this side, you have to continue using it on this side as well. And likewise, if this scale went to the bottom below the 0, whatever you use at the top here, you'd have to continue using the same scale at the bottom. Okay, and so they plotted the points that they found, and then they were able to use that to answer the questions asked. Okay, so I'll skip that and just go straight to, okay, we have some questions here assigned for homework. Okay, so you're going to be using the zero product principle to solve these. Here, they want you to factorize and solve. And then here, they want you to use the formula. Well, there's only selected questions. So whatever question numbers you see here, those are the questions you're going to do. And then there's another question on the end there for that section. For the next section that we looked at, 7.1, okay, we have a few questions to do. You're going to need to use a graph to answer, to answer all of these, but just the selected questions you see at the top, 1, 5, 9, 13, 17, 21, 25, and 29. Okay, so I think that's it, and these are your answers. These are your answers for 7.1, your answers for 6.5, the part that we look at today. And that's basically it for today, unless you have a question.
No, that's it. Thank you.
Okay. All right, thank you too. All right, and then next week we should be continuing with more graphs. Okay then?
Okay.
Yeah.